Reasons to have a blow-by. What's happening now? Why is not turning on the light? Okay, this is one of the reasons. This is run out inside of the cylinder, that it's not correct dimensions, and in some spots it's more tight, and some other spots it's more loose. The piston ring is not gonna seal properly, and you will gonna have a blow-by. Okay, like I said, in one case, the cylinder is out of specs, it's completely all over the place, okay? And you have a blow-by. The piston ring is not sealing properly, obviously, alright? And that's what you get. Now, you can have, let us say, one very nice, round, perfect cylinder, but the piston to cylinder wall to don't be right, and to have a piston rattling, for example. It depends the material of the piston. You can have it, let us say, on the cold start. That means every time that you start the car and you hear the rattling of the piston, you have also more wear until it warms up the piston and expand. So also this in the future will gonna cause you blow-by, because it's gonna compromise the cylinder, also the piston itself, and the piston rings are not gonna be happy. Then piston rings. If you open top piston ring especially, okay, but also the second. If you remove the piston ring from the piston, and the piston ring is there, and does have a tall tension, you understand that you're gonna have a blow-by, right? Or if it has a burn spot, let us say, or something. Usually it's expanding, and then when you remove it, it's like this. Then another reason that you have a blow-by, melt piston, let us say, for example. You have seen a couple of times before, I have shown you. I don't want to open the boxes right now. If you melt, let us say, a piston, because of the spark plug, because of the ignition coil, because of a faulty fuel injector, because of high intaker temperature, because of the ignition timing, because you're running lean, 1 million things, anyhow, you can have melt piston or cracked piston, and you're gonna have a blow-by. The most common thing is that, you know, you're driving normal the car, you don't have a blow-by, but when you are boosting the car, because of the boost obviously, then you have much more blow-by. Now, if somebody built for you an engine for a daily use, and pay attention, it's different daily use, different for dragster, let us say. Different to have a piston rattling, let us say, on the cold start, and to have much more clearance because you want to spray nitrous, or you want to spray, I don't know, because you want to burn different fuel, and you want to have it for competition, you want to have it, let us say, for a season, that you'll have to open it again before the next season of the engine, and different for daily use. Daily use, you cannot give, let us say, an engine with a piston rattling at the cold start, because, for this reason, because of daily use. So you cannot you cannot tune, let us say, the car, if you want my opinion, you cannot tune it lean to get the maximum output, or let us say to be based on methanol. Yes, you can, but it's not the ideal, because we are talking about daily use car. It's a different story. Now, if you burn a piston ring, that means if the piston ring does have a tension, it's burnt. If you melt a piston, if you burn the cylinder wall, that I have seen also this one from some people that I was playing with ethanol, and they explode also the turbo at 2.5 bar. So the mechanic, he cannot help you on that. He cannot do something about that to prevent that, because to prevent, let us say, melting a piston, for example, or burning something, you need to have much more extra clearance to survive. That means you're gonna apply more boost, you're gonna have some blow-by, and then you can go ahead. But again, like I said, it's not for daily. When you have correct on specs pistons and cylinders and everything's fine, you put it in. And then it's the same thing, let us say, when you have a bone stock car, if it fails, let us say, no, it's gonna help you, the ECU, it's gonna be fast enough. But when you're reaching on the limit, it's gonna be much more critical, much more difficult for the ECU, if you like. Especially if, let us say, some tuners, they cancel the fail-safe. I don't know how they're doing it, I'm not a tuner. I have seen that. I have seen a car that's misfiring. I have seen a car that does the high pressure pumps are gone, let us say, and there's no check engine and there's no fault, and it's continue driving the car with, let us say, 2 cylinders, for example. I have seen that before. If you're based on methanol, example, if you're based on methanol and you have a mixture 50-50 and you tune it based on methanol, and then you put, let us say, more water inside, distilled water, or if you put more methanol is not gonna have any effect. If you put, let's say, 70-30, for example, or if you don't have a methanol inside and you start push the car and the car is cutting, you can have this. Keep in mind that there are some cases that you see the fuel pressure 200 bar when you're pushing full, it comes the quantity control valve to the sky, then you have a fuel pressure drop to 150 bar, the car, it's not cutting, it's just only has one store fault inside that the fuel pressure goes low. It's not triggering the check engine. Don't ask me why, that's what I have seen. So, what I'm trying to say, that tune it for a daily, don't tune it for a drag race. That's what I want to say. I hope that I cover you. Thank you. Let me put also this inside on this video. In any case, if you have a melt piston, if you have burnt pistoning, or if the cylinder wall looks like a sandpaper, for example, because of the temperature, that the signs are over there, you know, everything's there. You can see also on the cylinder head. Usually the cylinder heads, the aluminum ALSI cylinder heads, they have some cracks. All the evidence are there. Nobody can delete it. When you open the engine, it's going to be very clear for everyone to understand what's happening, you know, from this point of view. Even let us say, if you spray so much methanol, also this, you're going to see the signs inside of the engine. Again, that's why it's mechanical. It's one-to-one. It's not a software that you can delete it. It's not, you didn't write something with a pencil and you can erase it, let us say. But again, there is also sign there, anyhow. So, again, excessive blow-by, you have, let us say, an oil cut scan, and you see the oil cut scan that's filling up. 99.99% it's from a blow-by. That's it. Thank you. I should mention also the engine oil that has a big effect. It depends what engine oil you're using, and depends how old is the engine oil. Some people, they say, you know what, I make only 1,000 kilometers, let's say, with engine oil. But you're pedal to the metal. It's not working like that. It's not like that. For example, you cannot find the oil that you're using, usually, or the oil that you tune the car with, and you find, let us say, 0W30 instead of 10W60. It has big effect. Keep in mind, usually, it's giving up one piston, or two pistons, let us say. It's not more than two, actually. The strongest cylinder, the cylinder that's producing much more heat, and it's sealing much more, this is the one that we're going to give up first. Or let us say, example. I have mentioned that how many times? I'm going to mention that again. Screw it, I'm going to put in one video, I'm going to put excessive blow-by to have it all together. Example, you have a pistoning gap 0.55, right? The same thing what I'm saying right now, I have said that before. I don't remember where I put the video. You can have one piston ring, let us say, can be 558, all right? If you go more down, and you can have also more numbers, it can be 553, correct? So, then the same thing is happening with the cylinder. You can have, let us say, a cylinder 83.001 thousand millimeter. You can have a cylinder that's going to be 83.008, example, and you can have a cylinder 82.997. You can have these numbers. Usually, more tight, more sensitive, more power. More loose, it can survive more, let us say. Again, there is a limit. It's not. This doesn't mean that we're going to make the cylinder 84 on 83 millimeter, let us say, piston, and we're going to run. After that, you're going to have a rattling. But when you're like this, you get the picture. The small details makes a difference. Then there are more numbers behind this. That means even if you go, let us say, here, and you're exactly, the next one, you're going to be different. This, I said here for the piston ring gap, I said here for the cylinder wall. Here we're going to say for the spark plug. Spark plug, it can be the gap 0.55 millimeter, alright? And it can be 556. It can be 0.551. You're measuring with the filler cage, right? So these small details, example, as an example, you have 0.553 pistoning gap, okay? And you have spark plug, let us say 556, bigger gap. And you have cylinder, let us say this one, that's more tight. When you are going to the limit, when you are tuning to the limit, this will gonna be the number one cylinder that will gonna give up, because this cylinder will gonna work much more hard, will gonna produce more temperature, will gonna be much more hard than the other cylinders. If it makes sense what I'm saying. Exactly the same thing what I'm saying now, I have mentioned that before. In any case, put it all together to have it here. This was some questions some people they're asking me. Fortunately, not very often. And for the end, let's see how many times I'm gonna say that. how many times I'm gonna finish the video. Why I'm measuring in millimeters and not in inches. First, because this is how I get used to it. Okay. And second, even if I was measuring in inches, I'm gonna convert it, I'm gonna go to millimeters. Why I'm saying that? Because you're gonna be much more precise. What I'm saying by that, yes, you can change, you can get a different tools to have more increments, let us say, to go more down, definitely. But let's be realistic. You have, let us say, a tool that's measuring in inches, and you're measuring 1,000 of an inch. Okay? 1,000 of an inch, it's equal with 0.025 of a millimeter. Alright? You know the clearance, I have mentioned a couple of times before the clearance on the European engines. Alright? That means when you have 0.002 of an inch, this will gonna be 0.05 of millimeter. So from 1,000 to 2,000, you're already out of specs. Like this. Again, yes, you can get a different tool that you can measure it more down. That's more expensive. But it's more expensive actually than millimeters, and to me it's much more precise. Because here I have 1,000, here I have 25,000. If it makes any sense. That's the reason why it's much more easy to be precise, and for me at least, that's whoever used inches, let us say in all of his life, obviously it's more easy to use inches. For me, I'm using all of my life millimeters, and I believe that it's much more accurate with the current tools that you can find in the market, and you don't have to spend a fortune, let us say, to start getting much more precise tools. Again, both tools, they are the same. You can convert, let us say, the tools in inches and millimeters. It's just only how they're traveling inside, if you like. Not in all of the cases, some of them, I'm saying. Don't misunderstand what I'm saying. This has effect also. And there is also a limit. That means even if you want to be precise, you get all your measurements at 25 degrees Celsius, all right? Between 20 and 25, not more than 25, not less than 20. And you are measuring 1,000 of an inch. He can screw you up the next digit. That means you can be, let us say, precise by plus minus 2,000 millimeter. Again, the tightest cylinder, you're gonna give up first. Not only, sometimes not only, let us say, the piston rings. Maybe you're okay with the gap, maybe you get more gap because you know that some people that are pedal to the metal, or some people that are tuning very hot, and you have a bit more clearance, it can give up the head gasket. If you have pre-ignition detonations, let us say, you can destroy the threads inside of the engine block. I have seen also this before, it's not the first time. So all this has effect. All this, everything, it's ending up to your measurements, to your hand, how you're measuring it. The most important thing is to be consistent. That means to get the same readings. The same thing also with the weight. You see that the scale that I'm using, it's measuring 0.1 of a gram, all right? It's not about, if I measure, let us say, here, and then I go, let us say, and I measure another scale, you're gonna give me different numbers. The thing is that each time that I'm gonna put the part on the scale, I'm gonna have, let us say, plus minus 0.1 gram. In the worst case scenario, 0.2 grams, if I'm sloppy, for example. But usually it's 0.1 gram plus minus. That's a little bit, it's not so much. The same principle also for the weight, how you're gonna balance something. You can always go more precise if you want. But again, we are talking about daily use engine, that this precision, it's not existing even from the factory, keep in mind. Okay, I hope that that's the end, and I don't have to add anything more than this. And I hope that I cover you. It has effect also the valves. There is a possibility to say one valve to seal better than the other. If one valve it seals better than the other, that's why I'm lapping the valves. I'm lapping the valves even when it has a new cut on the seat, new valve, let us say, new valve guide, and everything's perfect. I'm lapping the valve to make very fine, let us say, where it sits to be as much as possible the same. But again, imagine, let us say, you're trying to close the engine and something comes inside of the intake manifold, one piece of sand, for example, and it's staying between the valve and the valve seat on the number 1 cylinder, on the number 2 cylinder. You're not going to have any effect. You're going to work perfect engine without any problem. The thing is that this cylinder is not going to have the same compression like the others. So this will not going to have a problem, let's say, example, to melt a piston. It's not going to be the number 1 from this point of view. If it's leaking, let us say, exhaust valve or intake valve, and you spray nitrous, then you know what's happening. That's it. That's it. It's not only if it seals the valve, if it sits the valve properly on the seat, it's not only about if it has a dirt. It can have a small spots, small marks, let us say, that sit in the valve. On the direct injection, I have shown you a couple of times before I lap the valve, that has some imperfections up the valve. So again, I didn't cover everything. I didn't cover everything. I just, for me, I scratched the surface. I went a little bit deeper than the surface. Yeah. I can explain, we can open this conversation and talking for days. The thing is, keep in your mind that for mechanical parts, all the evidence are there. I have also some people that said to me, you know what, I ran my engine only for 100 kilometers, all right, and then I have this problem. And you're opening, let us say, the engine, and you see slightly bent head gasket, and you see the cylinder walls inside to be disaster. Okay, so you realize that this is either the cylinder is gonna be completely out of specs, let us say, or there is something else happen there. Anyhow, this is big conversation, like I said, and each case it's different conversation. You have to see. The thing is to don't miss something when you're opening the engine properly. Just don't throw down the parts, let us say, and look each part individually to see what caused that. You can get also some measurements at the same time, obviously, to understand what's going on. It's more important to understand why it happened. You have to pay attention there, and to try to see if you can make it better, let us say, from this point of view. Yeah, and this is also what I said before, that it matters so much the experience, because when you see, let us say, an engine with 50,000 kilometers, 100,000 kilometers, 150,000 kilometers, 200,000 kilometers, and you see the wear inside, and you see that this was bone stock, this was tuned, let us say, this was have a turbo upgrades, it was running with a methanol, let us say. This also experience to see how it's the wear inside, let us say, how much can survive, the bearings, all these things. Don't go there on the bearings. It's different chapter. Yeah, it's big story. And definitely I'm not gonna cover it in a 10 minutes video. Thank you.